Hello everyone, in this lecture I'll be talking about quadratic mean, which is a little extension of arithmetic mean, also known as root mean square. You can see the pointer right here, that what does root mean square is all about. So basically what I'm doing here is I'm finding the square of the variable, then finding mean of it, then finding square root of it. So it's a little different from arithmetic mean. I'll be explaining a little bit about that, how it is different from arithmetic mean. And here's the formula for root mean square or quadratic mean. You can also understand it as RMS, root mean square. And this is how the formula is given. And I'm going to compare it with the arithmetic mean formula now. If you could recall the arithmetic mean formula, it was something like x bar is equal to sum of I is equal to 1 to n xi divided by number of observations. This is for ungrouped data, and for grouped data the formula was sum of I is equal to 1 to n fi xi divided by sum of I is equal to 1 to n fi. Now the modification is xi has been replaced by xi square. You can see that. So I'm going to go to the next slide and we will be doing some questions on quadratic mean for ungrouped and grouped data both. So that is it. Here is the first question. That means you got certain numbers and I want to find out the quadratic mean for these numbers. So certainly from the last slide, RMS, root mean square, or you can simply say it quadratic mean, and the formula was sum of I is equal to 1 to n xi square divided by n, number of observations. So you could see that number of observations here are 1, 2, 3, 4, 5. 5 observations are there. So how I'm going to solve it out is, it will be minus 5 square plus 6 square plus 3 square plus 4 square plus 7 square divided by 5. Oh, I forgot one thing. There was a square root also. So this whole thing need to be actually square rooted. So when we figure it out, if I square them, now it's going to go something like this. It's going to be 25 plus 36 plus 9 plus 16 plus 49, and then divided by 5. So the square root is, I further solve it, it's going to be 135 divided by 5. That gives me a square root of 27, and that comes out to be 5.9. I'm not sure 5.9 or 5.19, need to cross check it. So that is what I'm going to get. Let me just cross check it a bit. Now if you calculate the arithmetic mean for same particular formula, for same particular data set, then in that particular case you will see that the arithmetic mean for same data set is actually a little different. Now we need to understand that how this whole data set and how quadratic mean is different from arithmetic mean. So it is going to come out to be 5.19. sorry, my bad. Now if I'm going to find out the arithmetic mean for the same numbers, just let's see how the arithmetic mean is going to be. So I'm going to find out arithmetic mean here, and that is going to be negative 5 plus 6 plus 3 plus 4 plus 7 divided by 5. Right. So what is going to be the arithmetic mean? If you calculate it, it will come out to be 3. Now let's see exactly, let's plot this particular data and let's see how the things are different. Let me change the ink color if I could. Fair. Okay, pick up the yellow. I think it's done. Yeah, no it's not. I'll just pick it up again. Okay, I'll pick, let's see, green. Fine. Let's see. So this side is negative infinity, this side is plus infinity, 0 somewhere here, and it's 1, 2, 3, 4, 5, 6, 7, and so on. On this side it is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and so on till negative infinity. Let's plot these numbers. So my arithmetic mean is 3. Let me change the color once again. Okay, my arithmetic mean is 3. That means right here. This is where my x bar sits, which is 3, equal to 3. Now what is my first observation? Negative 5, which is here. The second observation is 6, which is right here. Third observation is 3, right here at the mean itself. Then I've got a 4. The next observation is 4, which is right here. Then I've got an observation 7, which is right here. Now if you see that how exactly the values are distributed, there is exactly one value on the left of arithmetic mean and 3 values on the right hand side. So balance seems a little bit disturbed. But when I am going to plot the quadratic mean right here, how the things are going to change? Let's see. So once I'm going to put my quadratic mean, which is 5.19, that means somewhere very close to here, that is quadratic mean. Now you can see right here 2 values are on the left and 1, 2, 3 values on the left. So in this case quadratic means looks a more balancing figure in comparison to arithmetic mean. So you can make it out whenever you are involved with negative values and you want to find out the mean of the magnitudes. The quadratic mean is more suitable measure. You can find more applications of quadratic mean. Now I'm going to go for a grouped distribution. Right here if you see, then I have an x, I have an f, so it's a discretely grouped distribution. I have frequency associated with it. I know my formula for quadratic mean here. It is square root of sum of I is equal to 1 to n fi xi square divided by sum of I is equal to 1 to n fi. A little longer, that's it. So that's how the formula is. So let me go ahead, let me produce a table. Let's calculate it. I have x, I have f. I'll be calculating x square and then I'll be calculating f of x square. So what is x? 5, 6, 7. That comes out 362. X square is going to be definitely 25, 36 and 49. 5 square is 25, 6 square is 36, 7 square is 49. What is 25 into 3? 75. 36 times 6, it is 216. And 49 times 2 is 98. Now here I'm going to sum them up. Okay, I'm sorry, I just need to clean it up a little bit. Right here this line has to go. Okay, fine, it's look good. Okay, so that is sum of fx square and that is going to give me 389. That's the numerator I have calculated. I need a sum of f. So 6 plus 3, 9 plus 2, that gives me 11. I'm going to substitute all these values here. It's going to be 389 divided by 11, and if I calculate this entire figure, it's going to come out to be 5.94. So that's how the quadratic mean can be calculated for discretely grouped data. And of course, if you are given with the class intervals, you can calculate x by using mid values. So I'll probably be talking about more problems of quadratic mean. The trade-off is actually finding it has a huge application in sciences, applied sciences, the quadratic mean, in chemistry or probably in physics and in some other areas of such kind. So we can find more applications of quadratic mean. Thank you very much. Thank you.